Welcome to this lecture on S3 Object-Oriented System in R. My name is Dr. S. I. Singh. I am a faculty in the Department of Computer Science and Engineering, Tezpur University, Assam. I am grateful to TLC, Tezpur University, for giving me opportunity to develop this lecture. Well, R is the fourth most popular programming language next to Java, C++, and Python. R is basically a functional programming language. However, it also supports object-oriented programming style. In fact, R packages are increasingly object-oriented. Therefore, an understanding of object-oriented supports in R will enable us to use R packages properly. Moreover, we can seamlessly integrate R code to other programming languages like Java, C++, and Python. In the first part of my lecture, we will talk about basic terminologies underlying object-oriented programming style. This includes object, class, polymorphism, and inheritance. Then we talk about S3 system. S3 system is used in the base and statistical packages of R. It's also the most commonly used system in grant packages of R. There are other object-oriented systems available in R, such as S4 and R6. S4 is similar to S3 but with more formal approach to object-oriented programming. R3 is similar to object-oriented style of programming available in languages like Java and C++. Finally, my lecture is concluded with some important remarks and useful references. Object. Object is the building block of any object-oriented program. Object is defined as an encapsulated unit of data and operation on this data. Data parts of an object consist of one or more fields or slots, and operations are also called methods. So for example, in a banking software, account of a customer can be an object. An account object, apart from many other things, will have an account number, the name of its owner, and current available balance. Among the operations, withdrawal and the deposits are the main transactions one can perform with an account object. In object-oriented programming, objects are created from a class. This process of creation is called instantiation. Class. A class defines the blueprint of an object. In this blueprint, the fields and operations are specified. Fields are variables declared with their data types. Methods are simply functions having a name, a return type, and maybe a list of parameters. During object instantiation, A special method called constructor is used to initialize the fields of the object. Well, here is a picturization of class and object. Left-hand side is a class. It has got fields or slots which are variables with their type informations, methods which are functions with return types and parameters. Right hand side is an object created from this class. Note that all the fields are initialized by the constructor during the object creation process. It is via the operations the value of these slots of an object will be modified externally. Inheritance. Inheritance enables us to create a new object from one or more existing objects. The newly created object, known as the child object, will share the data fields and methods of its parent objects. Therefore, inheritance provides a mechanism for reusing of existing code in object-oriented programming. Another thing inheritance provides is polymorphism. Polymorphism means one function with many implementations. For example, we can have implementations of a method in a parent class and as well as in the child class. Now, depending on which object type the method is called, one of the methods will be selected by polymorphism. Well, after having discussed the basic concept of object-oriented programming, let us now examine how these concepts are implemented in S3, which is the original object-oriented system in R. Everything in R is object, however everything is not object-oriented. This means there are two types of object in R. The first type of object does not have their class attribute. Such objects are called base objects because other objects are constructed from them. There are around 25 base objects in S3, which include most of the basic types in R. There are two useful commands in R with that we can check the object information of an entity in R. The first one is.object. This command checks whether a given entity in R is an S3 object. Here 1, 2, 3 is a numeric value and not an S3 object, so it returns false. The second command belongs to the sloop package. So this command will tell the type of the object of an entity in R. Second type of object in R is object-oriented object or simply S3 object. These objects have their class attributes. Let us see. So the previous two commands can be used to check whether a given entity in R is S3 object or not. There are certain differences between S3 object and object in classical object-oriented programming language like Java and C++, etc. In classical system, object is an instance of a class. A class is defined first and then object is created from it. However, S3 object does not require any formal class definition. Class name is simply associated to an object as one of its attributes. Next, S3 objects do not have both fields and methods. In S3, methods remains external to the objects. Therefore, S3 object consists of a list of fields or slots and a class attributes. Taking our account example, so let us create an S3 object. First, list of its fields. So account number, let's say some 1, 2, 3, 4, 5. Folder name, so Mr. Kamal. Balance. So this two line creates an account object. The first line defines the list of slots in that object, and second line sets the class attribute to the account class. So let's see what is whether it is created or not. Okay, yeah, this SE1 is created. Its members are accordingly displayed here. So by using the previous command, we can check its object information. So this is an S3 object. The second command, so this is S3 objects. The member of S3 object can be accessed by using dollar operator. So let's try to access the balance of our account object. SC1 dollar balance. So this way, dollar operator can be used to access the individual data slot of an S3 object. Since S3 object is informal, R does not perform any checking while setting the class attribute. Say let's see the class attribute of our object is now account, so we can set it to any class name, for example student. So here the attribute is changed to students, but account SE1 is not a student object. So this way S3 system does not provide the checking while assigning the class attributes to an object. We can design our constructor to enforce more checking while creating S3 objects. For example, our account constructor can be defined like this. So using this, we just try to use this constructor. So first define the account object, the account constructor. This is a function. So it accepts a account number. This is a string. Name of the account holder. This is also a string, and balance amount. This is a real number. So here we can provide the checking for the data type of its argument. So this line will check whether the given arguments are strings and real number. If they are, then we proceed to the account creation. So we set the account number to the input account number, account holder name to the input, and balance to set the class, and finally return the object. So this is our account constructor. So once the constructor is defined, we can use it for the creation of account with proper checking. So let's see another account using this constructor. So call the constructor here by supplying the appropriate argument value. The first one is the account number, let's say 012 123 46 Mr. Hussain, and balance is some value. So this creates our account. Let's see. So this way, constructor can be used to create S3 objects, and we can enforce more checking using the constructor during object instantiations. One fundamental difference between S3 objects and classical object-oriented object is in the use of methods. In S3 methods are not directly associated to objects or class. Rather, methods belongs to generic functions. A generic function is an interface to many methods implementations. Depending on the value of the class attribute of the object on which the generic function is called, one of the implementation is used. Therefore, generic functions are polymorphic functions. In R, we can check all generic functions available in one particular session by using the command methods. So there are 157 generic functions available in this particular session of R. And for one generic function, we can check the different implementations that it can provide by using the command methods. Here print is a generic functions. So there are altogether 205 in the implementations of the print generic functions. Now let us examine how generic function dispatches to a particular method. All generic functions use the command use method. You can verify it from R. So for the print, so you can see here the print generic function use the command use method for dispatch. The first argument in the use method command is the name of the generic function, and it is always mandatory. The second argument is optional. It represents the object whose class will determine the method to be dispatched. If it is missing, then the first argument of the generic function is taken as the default. The use method command looks for a method whose name is the form generic function dot class name, where class name suffix must exactly match the class attribute of the object. The exception is the default suffix that is executed if no such function is available. So let us check this from R, how a call to generic functions and its dispatch mechanism works. Say okay, install this loop and we can use. So here we can see the default implementation is used when we call the print generic method on our account object. Remember, we have changed the account object class attribute to students.